Hello everyone. In today's lecture, we'll discuss different steps involved in drawing of butterfly diagram for decimation in time algorithm of FFT. Right. So let's consider one example that we are given 8 point. We have to draw 8-point DIT FFT. All right. That means we have to obtain DIT for n equal to 8. All right. Our number of input samples will be 8, as well as a number of output samples are going to be same. All right, here you can see a flow graph. Right, we'll learn how to draw that, okay, step by step. All right, step number 1, this process is bit reversal. All right, see, we are given 8 bits, 8 samples actually. Right, so I'll write their index values first. Okay, it will range from 0 to 7. Okay, now write the binary equivalent of these index values. Right, for 000 it is 000, for 0 it is 000. Likewise for 1 it is this thing. Now for if we consider 4 it is 100. Likewise for 7 it is 111. Now what we need to do is we need to reverse the bits. That means most significant bit in binary representation will become least significant in bit reversal order. All right, for instance you can consider this one. Right, this is 011. Right, so in bit reversal order it will become 110. Okay, the last bit will come first and then first bit will go last. All right, likewise we have will do for all the bits. All right, now these reversed bits can be mapped to index values, like 000 is 0, 100 is 4. Right, and for some instance if we consider 101 it is 5, 011 it is 3. So we get some order. All right, in which we are going to pair the bits, in which we are going to pair the samples. Right, so we'll pair 0, 10, 4th sample. Right, likewise we'll pair 2 and 2nd and 6th sample. Okay, then we'll pair 1st and 5th sample, and we'll pair 3rd and 7th sample. All right, so this is done. This is actually done to get the values at the output in order. That is, we'll start from 0 and will end at 7. Okay, 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so for time domain we'll consider like this, and at frequency domain, I mean the DFT of all these things will be in order 0, 1, 2, 3, 4, 5, 6 up to 7. Okay, so let us mention these values in this order only in the butterfly diagram in input section. Okay, first of all, as we know, n is 8. Right, so what we need to do is just pull 8 straight lines. All right, these horizontal lines. Okay, and mention all the samples on input side in bit reversed order. All right, see, you can see here 0 and 4 are paired, 2 and 6 are paired, 1 and 5 are paired, and 3 and 7 are paired. Right, now moving on to step number 2. In step number 2 we'll calculate number of stages. Right, we are given n equal to 8. Okay, means n number of samples is 8. Okay, so number of stages will represent with capital M, that is log of base 2 of n. Okay, substitute this n with 8. All right, and we know log to the base 2 8 is 3, so we get number of stages to be equal to 3. All right, or alternatively, you know, this is a radix 2 system because base is 2. Okay, so 2 to the power m equal n. Right, we know this from yesterday's last lecture. Right, so n is given to us, that is 8. Okay, so from here we can easily estimate the value of m. All right, that is 3. Okay, so m equals 3. What it implies? It implies that we have 3 different stages of butterflies. All right, first stage is this one, second stage is this one, and we have third and last stage is as this one. Okay, in step number 3 we'll have to calculate the number of complex multiplications, and in step number 4 we'll calculate complex additions. This we've already discussed in our last class or last lecture. All right, so complex multiplications will be given as n by 2 log to the base 2 n. All right, substitute n equals 8, you'll get total complex multiplications to be 12. All right, likewise for complex additions you can determine complex additions by this formula. Right, n log to the base 2 n. Right, so you can easily substitute n equal to 8 and you'll get 24, which is much less than complex additions and complex multiplications in DFT. All right. Okay, then we have step number 5, right, where we'll determine the number of sets of butterflies in each stage, right. This can be calculated using this formula, right, 2 to the power m minus m, where capital M is total number of stages, all right, total number of butterfly stages, and m is the stage index, all right. It can vary from 1 to 3, all right, stage number 1, 2 and 3, all right. So let's check it out. For stage number 1, you have to substitute this small m with 1, all right, and we know capital M is 3, so this becomes 4, all right. Likewise, capital M will remain 3 all the time, and you will change these values, okay, small m values, and you get these things, these numbers, right. This basically gives you idea that for stage 1 we'll have 4 set of butterflies, sorry, and for stage number 3 we'll have 2 set of butterflies, and stage number 3 it will have 1 set of butterfly only, okay. So let's see. So here's a butterfly diagram, right. I've already marked the inputs, okay. Stage 1, stage 2, stage 3 I've marked, right. So these are my butterfly stages, stage 1, stage 2 and stage 3. Now for stage 1 we have already calculated that it will have 4 sets of butterflies, right. So as you can see, there are 4 sets of butterflies, right. Likewise, for stage number 2 we'll have 2 sets of butterflies, okay, set number 1 and set number 2, all right. Likewise, for stage number 3 there will be only 1 set of butterfly, all right. Now step number 6 is separation between input and outputs of each butterfly in a stage. That inputs are separated by how many samples, right, or outputs are separated by how many samples, that is given by 2 to the power m minus 1, where m will vary from 1 to up to 3, right. So let us find out for stage number 1, okay. For stage number 1 your m will become equal to 1, right. So let's substitute m equal to 1. So 1 minus 1 will become 0, and ultimately you will have 1 only, means for stage number 1 your inputs are separated by 1 sample only, okay. Likewise, for stage number 2 it will be separated by 2 samples, okay. Inputs or outputs, they are separated by 2 samples, all right. For stage number 3 your inputs and outputs are separated by 4 samples, okay. If you see this diagram, we have separation between input stages by 1 unit, right, or 1 sample, okay. Likewise, here it is by 2 units, 1 and 2. Likewise, for third stage it is 1, 2, 3 and 4, all right, okay. Same is applicable to output side also, okay. Here it is separated by 1 sample, again this side is separated by 2 samples, this side it is separated by 1, 2, 3 and 4 samples, okay. We'll use these values in step number 7 to find out number of Tweedle factors to be calculated, right. Actually it determines the exponent value of Tweedle factor, right, k value, okay. And stage number 7 will determine the Tweedle factor component, Tweedle factor exponent, right. Tweedle factor exponent is k, all right. We generally write Tweedle factor as w, in the base it is n to the power k, okay. It is coming from the equation we have calculated for FFTs, right. Now this k is given as n multiply with t is some integer, right. N is it is given 8, right. For this particular example it is given to be 8, right, and 2 to the power m, okay. This small m is 1, it can range from 1 to 3, right. Now we'll calculate for all the 3 stages. Let's consider stage number 1, okay. So here before calculating this, let's go to step number 6. These values actually in number 6 will determine how many values of t we have to consider for particular stage, right. Likewise, like for stage 1 we'll be considering only t equal to 0, okay. For stage 2 we'll be considering t equal to 0 and 1, okay. There are 2 values possible, okay. Now for stage 3 it will be see, there are 4 values possible, okay. So t can take 0, 1, 2 and 3, right, 4 values, all right. So for stage 1 we'll consider only t equal to 0, okay. So let's substitute t equal to 0 right? N is given, that is 8, and 2 to the power m is 1, okay, for stage 1. All right, and t will substitute 0, so this comes out to be 0, okay. This means for stage number 1 I'll consider twiddle factor like this, w in the base 8 and to the power 0, right? Okay. Now for stage 2, as we have already seen that we have to calculate for two different values of t, right? 0 and 1. All right, so for 0 your k comes out to be 0 only, right? But for 1 it comes out to be 2. All right, be careful about this thing, right? With change in state your value of small m will change. All right, so this time in stage number 2 we'll have two different twiddle factors. One is with power 0 and other one with power 2. All right, okay. From step number 6 we know that for stage 3 we'll require four different values of t. All right, 0 1 2 3. So we'll generalize this thing. We'll find general value of k, and we'll substitute 8, right? And m we have substituted 3, right? So this becomes 8, so 8 will cancel out. You are left with t only, okay. So if you substitute for t you will get 0 1 2 3 only, right? That means for stage number 3 we'll have four different values of twiddle factor, w8 to the power 0, w8 to the power 1, w8 to the power 2, and w8 to the power 3. All right, step 8 is exponent repeat factor. That means those how many times those twiddle factor will repeat themselves, okay. I mean k will repeat itself, okay. So this can be calculated as 2 to the power capital M minus small m. So capital M is fixed, that is 3, and small m is 1 2 or 3, it can be, okay. So let us calculate for step number 1. Capital M I have substituted 3 all the time, right? You have to change small m, right? 1 2 and 3, so I'll get 4 2 and 1. All right, what does that mean? That for stage number 1 your exponent will repeat 4 times, okay. Exponent will repeat 4 times. Likewise for stage number 2 it will repeat 2 times, okay. And for stage number 3 your exponent will repeat only 1 time, okay. Means no repetition at all, okay. So let us see in butterfly diagram how that is done, okay. Now you know the value of exponent and its repetition value, okay, its repetition factor, okay. Now for stage number 1 we have calculated exponent to be w8 to the power 0, all right. And from step number 8 we know that this will repeat 4 times, okay. So let us see, this is my stage number 1, and see this exponent, this twiddle factor will repeat itself, okay. To the power 0 to the power 0 to the power 0 and to the power 0, it will repeat itself 4 times, okay. Likewise we know that for stage number 2 we have two exponent values, right? W8 to the power 0 and W8 to the power 2, and we know by step number 8 that each of these exponent will repeat themselves twice, okay. There will be two instances of these twiddle factors, okay. So W8 to the power 0 and W8 to the power 0, right? And for step number 3 we know that there is no repetition at all, okay. And there are 4 exponent values, okay. So we'll have 4 different values, okay, for twiddle factors. So I have to write it like this. All right, ninth step actually gives you idea about the number of butterflies per stage, right? We know n is 8, okay. So it will be we can calculate it by simply having this relation, right? You substitute n equal to 8, so 8 by 2 equals 4. That means we'll have 4 butterflies per stage, okay. See, for stage number 1 we have butterfly 1 2 3 and 4, all right. Likewise for stage number 2 we have 1 2 3 and 4. Likewise for stage number 3 again we have 4 butterflies, okay. Now as all the twiddle factors are in place, right, for stage 1 we have 4 butterflies, right? 1 2 3 and 4, okay. So we have pair of 2, okay. This x0 will pair with x4, all right. So this value and this value we can calculate by standard results, okay. To have this value, we'll put 1 here, right, and multiply this with -1, right. The values on the horizontal axis, they will get multiplied, and the values on the diagonal lines, they'll get added up at these nodes. All right, so we get here we get x0, right, plus what, this x4 will get multiplied with this twiddle factor, right. W80 multiply with x4. Okay, likewise on this side we'll get this x0 coming from this side, right, this side x0, all right, minus this product, right, x4 multiplied w8, it will get multiplied with -1, right. So this becomes w80 x4. Okay, likewise we get all those values, right, here, here and here, right. This expression is actually coming from this equation, right, equation number 1. Let us mark this equation number 1, and the second one, this actually is coming from this equation, right. For details you can watch the video, okay, in the description below. All right, let us name this expression as S1 naught, stage 1 zeroth sample, right. Likewise, let us name this sample as S1 1. All right, similarly I have mentioned all the values in form of S1, right, S1 0 to S1 7. Okay, now these values will now act as input for next stage butterflies. Okay, in similar way we'll perform this computation, right. This S1 we are getting here, right, and this S1 2, S1 naught and S1 2 we are getting for this butterfly, right, as input. Okay, so we can have output as S1 naught, right, plus, and this side it will get plus, right, this is 1, let's mark this -1. Okay, so S1 naught plus S1 2 omega 8 to the power 0. All right, likewise this side will write S1 0 minus, because this S2 will get multiplied with omega 8 to the power 0 multiply with -1. Okay, so minus omega 8 to the power 0 S1 2. All right, let us mark name this value as S2 naught, right. Likewise value we get here is S2 1 and so on. Okay, now these values of S2, these samples S2 0 to S2 7, they'll act as input to stage 3. All right, so if I consider first butterfly, so its input is S2 0 and another input is S2 4, right. So this side it is we're multiplying with this one with 1. All right, and this S2 is getting multiplied with W80 and also with -1. Okay, so this at this point will get S2 0, right. This side on horizontal line the values will get multiplied, and on these diagonal lines they will get added up. All right, so plus what, S2 4 multiply W80, S2 4 multiply, or we write it in this way, W80 multiply S2 4. Okay, in similar way on this point we'll have S2 0 minus W80, the inputs will remain same. Okay, S2 4. Okay, similarly we can calculate for all the other values. Okay, let us call this equation as x0. All right, so next value automatically will become x1, x2, okay, x3, x4, x5, x6 and x7. All right, so this side it was time domain function, and these are transformed functions, right? To have these values x1 means these DFT values from x1 to x7, we need to know these samples, right? On extreme left hand side, we need to know these samples, the numeric values of samples, as well as we need to calculate these Tweedle factors, right? So Tweedle factors, how will calculate? See, the Tweedle factor you are getting in the equation is of form wn to the power k. All right, so this can be written as exponential of this thing to the power k. Okay, further we can expand this by Euler's formula, right? Cos of 2 pi k by n, right, minus iota sine of 2 pi k by n. Now we have to substitute for k, right? Suppose if we are finding w8 to the power 0, right? So for this particular your k will be equal to 0, right? And n is fixed, and we know that is 8, right? We have already written here 8. So this equation will become cos 2 pi and k is 0 over 8 minus iota sine 2 pi k is 0, we know, and over 8, right? So that is how we'll calculate Tweedle factors. Okay, likewise we can do for w8 to the power 1, w8 to the power 2, and w8 to the power 3. These are the 4 Tweedle factors we are having on our butterfly diagram, right? The things in here will get more clear when we go for a problem, right? So in next lecture we'll consider one. All right, till then, thank you.